block. Here's 2 lines of HTML code. Here's a JavaScript block. Here's 2 lines of HTML code. And I'm like, that's great, but you should try doing it with a for loops. You don't have to. You could do that like 100 lines of code, or probably like 50 lines of code. But
I have like a do loop with a do loop with a for loop.
Whoa. So, first off, questions or things on your project? No? Good?
Cool. We're going on.
Okay. That's easy. Well, we only have 3 people that can ask questions. Oh, that's kind of strange here. How much have you guys talked about big data in your classes? Okay, I wanted to just have a short, this might take like 15-minute discussion about it. And then if there's no questions, then I guess we'll just be done. It's probably better off to use this time for project time anyway. Yeah, we're recovering from spending project time. My plan, and I put it in here, I didn't do the description yet. I will later tonight. We'll do sort of the same thing we did last Thursday. I probably will modify it and ask you to address similar but maybe slightly different things. So it won't just be quite a copy and paste, but I might ask you to touch on certain things. So, what?
Is that legal?
So I found some slide shares that were pretty good. I looked through a bunch of them. Big data analytics is such a big topic, and it's something you guys are going to come across either in interviews, just because it's like the hot thing, and they're going to want to ask you if you have experience working with big data. I mean, there's all sorts of reasons you're going to come across this. I'm definitely not an expert in it, but I think it's just good to kind of, to some extent, yeah, I mean, and we'll look at it today. There's a lot of ways the data becomes big. I mean, what's the simplest way that we think of? There's lots of it. There's a lot of other factors that they use to classify data as big. We're used to just, you have hundreds of megabytes of data. Like we crossed 1 million schedule events in our database. That's a pretty big data set if you wanted to analyze it. Now, oftentimes these big data sets are really, really big, like way bigger than that. I tell my students, like, the list of all people in the United States isn't really that big per se. 300 million, it's big, but it's not that big. So these can be much bigger than that. Am I misestimating it? No, I thought it was like 300 million. You're the answer guy. So I guess this is a book about big data that I've never read, but where these slides come from. Now, to some extent, big data is just putting a trendy word to something that's been around for a long time. The data sets they're talking about, the things we're doing with them, have been around for 30, 40 years. It's become more of a thing because 308. Computing power has let us collect a lot more data, and then things like Facebook and things where location tracking, there's all sorts of things that have grown our ability to track data. Plus, the newest big thing is the whole Internet of Things. So pretty soon, everything, including probably that stapler, will have a chip in it that reports back how many times someone staples and how fast they do it, because then they can use that information and manufacture a better or a cheaper to make stapler. So that's just adding to the data collection now that we can. I was going to bring in an Arduino and do an example of collecting data that you can do. It's super easy now. I just didn't have time to put it together, and I may do it next week or Thursday. But I mean, you can sit there and collect temperature data every second for as long as that runs, and you get a pretty big set of data from a $20 piece of equipment. So, yeah, the Arduino language is C-like. It's very similar to C. They don't call it C. It's its own Arduino thing, but for all intents and purposes, it's C. So there are some things that are so big that they have implications for everyone, whether we want it or not. Big data is one of those things. It's transforming the way we do business, and it's impacting most other parts of our lives. So the basic idea behind this big data phrase is that we're leaving this digital footprint everywhere we go. So it used to be the first place people started to see this was when you went to Albertsons and you had your discount card. That was solely so they could track what you buy and give you coupons based on it. And that's been, I think that started in the 90s probably. That was one of the first times where I think people, in a general sense, encountered being tracked continually. Though I don't think very many people were savvy enough back then to know that's what was going on, right? So it's like, oh, I get a discount. I mean, yeah. So now we've sort of moved away from some of those. Why do you think that's happened? How many stores have discount cards? Yeah, I mean, you have to compete with Walmart, who doesn't have them, but they just track everything through our credit cards. They can get all the same information. They look at your credit card number and what you bought today, and they can see what you bought last time. They don't need the cards. And people were annoyed by having extra cards, and Walmart didn't have cards, but it doesn't mean they're not tracking exactly the same thing. In the 90s, cash and check was still the dominant payment, and you couldn't track those. So then the stores get to have this big thing, oh, now we don't have for the cards and our prices are low, and then everyone's like, yay, but nothing's changed, you know, they raise their prices, you know, I mean, it's just, they shift it, so we're collecting a lot of data. Then really the important part is, what do we use it? How do we make use of all that data? There's a ton of data collected out there that's never used. One of our business strategies at Orbital Shift always was that we thought if you collected enough data about people's schedules, that there was probably value to that if you analyzed it. We never did it, and it never happened, but at some point, that becomes a sellable, you know, thing on its own. Like, you can sell the company and say, well, maybe we don't want the software, but we have this data, and that's valuable. So never came to fruition, but it was always in the back of our mind that we weren't going to delete anything. You just keep it. Nothing almost ever was deleted from the system. So basically, this guy from Google is just saying that up to 2003, we generated 5 exabytes. Yeah, exabytes. So it's gigabyte, petabyte, exabyte, right? I think so. That's a lot. I mean, it's big. But now we're generating that much every 2 days. And who knows when this quote was made. I mean, it's all of humankind now is 2 days. Yeah, so, I mean, there's a lot of data there. Now, just because we're generating it doesn't mean we're saving all of it, but it's generated. You can generate data, and I mean, depending how they look at it, what happens in your car when you're driving down the road? You're generating a ton of data that the cruise control is using to adjust your speed. That's not saved, it's thrown out. We're still generating it. What's that? You don't have cruise control?
In 2005, there's no cruise control.
Really?
Yeah.
That's
It's
weird.
super obnoxious. He's
My-
driving 174 miles a day.
My father-in-law has a Miata he bought, and not a great car, but he wanted no extras, and he could get that with no cruise control. It's like in 2010. Like, they sell cars without cruise control in 2010?
My car's 99 and it has.
Yeah,
I know, I have a 97 Blazer and a cruise control.
right. What kind of car is it? What kind of car do you have? Maybe it's a Mazda thing.
No, it has a top four.
Well, yeah, no, but I'm just saying, like, because the Miata had that option not to have cruise control.
couple months. I'm like, we're just going 70 for like 2 hours straight. It's nice to just.
I use mine going down Reserve Street in the morning because it keeps me from going over the speed limit, and then I just set it and I just
See that much better. I like it too.
So let's see. Listening to music, reading a book collects data. Music players collect data. Your smartphone, the smartphone collects a ton of it, which is super useful because then the Google Now gives you all sorts of really handy information that it can only do.
It was kind of scary on my birthday. Like I walked into Google and Google was made out of a birthday cake.
I mean, I get things on my Google Now page saying, "Are you headed to this place?" And I'm thinking, how do they know this? Like, obviously, if you're going to work, there's a pattern. But it happened the other day, and I had no idea how they were able to guess that. And I said yes, and then it told me how long it was going to take to get there.
That's scary.
It is a little scary. Credit card company, we already talked about it. But basically what they're saying is like everything generates data now. I mean, it's everywhere.
Xbox One gave me That's what my Google Now said.
So now they're saying like conversations are recorded because of Facebook and Twitter. Even your phone conversations may be recorded. Even your voice may be recorded. Well,
just record your voice.
it's recorded right now because of YouTube, and that's out there. So, I mean, photos. So we've seen the impact this has had. Hello, Tom. Talking a little bit about big data today. How'd the interview go?
I think it went pretty good.
Yeah.
18 people that applied to interview 6 of us.
This is for one of the tags for the district, right?
Yes.
Okay. And who was interviewing you?
Rex
Rex.
Hendrickson. He works right away in the business building.
Yes, I know. Yes. I know last time they hired. Well, no,
Don't say anything.
I could go
No.
give a recommendation. When they tried to hire techs last year, they didn't have a single person apply that had any kind of degree. And that was and it's Russ actually, Russ Hendrickson.
Okay, he said Rex.
Yeah, I think it's Russ, but the guys they hired ended up being really good, but he was concerned about that. That it shows that we just don't have enough IT workers when pretty good jobs are out there and not a single person applies that has a 2-year degree or certain certifications, anything for it. So you probably were a pretty good candidate since you have tons of experience. All right, so closed circuit cameras. So all those security cameras, a lot of that gets uploaded to some central repository. It's been a while now since I've heard much about it, but they were starting to, much like the cameras on the stop lights that they have a lot of places, look at using closed circuit and feeding that into FBI database where it's automatically scanning every single person that walks by and comparing it against a warrant list. And it depends on your perspective. Some of these things, I've always argued, if you're not doing anything wrong, what does it matter? But you're still giving something up. There's a fine line there. All it takes is a shift in politics and things, and all of a sudden, what wasn't wrong is wrong, and then you're in jail. So, sensor data. So this is what I was talking about, some of the Arduino stuff. But your smartphone collects with GPS, but it also has the accelerometer and the speed, so you can, on your iPhone, track your steps and all that stuff. You can be dang sure they're using that data for something, or they're saving it because they think they might be able to. I have a thing of Arduino sensors, 37 sensors, and they're all about this big. And there's sensors in there that can sense fire, humidity, temperature, all sorts of things. They're super small, so you can embed those in just about anything. Internet of Things, that's what I touched on. So we're connecting everything. it started, seems, well, obviously smartwatches. I used to hear a lot about fridges, you know, and recommending for you when you needed to buy things and that kind of stuff. But now we're seeing the thermostats, the Nest thermostats, the Nest smoke alarms that are connected to protect smoke alarms. I mean, here they're saying about like traffic sensors on the road that send data to your alarm clock, which will wake you up earlier because the road is slow. I mean, then the other thing, we're there on some of these things. They could do a lot of these things. It's just a matter of getting the public acceptance. I think I talked about it in databases. We haven't needed to have checkers or checkout at grocery stores for a long time. Everything except fresh vegetables and fruits has RFID chips in them. Walmart backs their truck in and their inventory system updates. They don't have to do each individual box or item. We could push our shopping cart right through a scanner and walk right out the door. We'll pay with your credit card. But people won't accept that because they're too concerned it's going to screw them, even though you're much more likely to get screwed by the person hand scanning your items than you are otherwise.
But from the store's perspective, people figured out that if they go through like the self-checkout, if they can put in different codes for vegetables, so it could be organic.
Right. Put the regular, yeah. But if it's RFID, then the store wouldn't have to worry either. So, I mean, that's why you see some of these fruits and vegetables and stuff now coming packaged. Like Walmart has the plastic things full of tomatoes and instead of individual tomatoes. So this slideshow talks about big data in 4 V's. There's a really short one I'm going to show after where the same guy adds a 5th V into it. But you see this V terminology a lot. So the first is volume. That's the obvious one. Lots of data. The other ones are much less obvious. The second is velocity. So how fast is the data being generated? Which, if you save it, will result in volume, right? But self-driving cars, you know, Tesla, those cars can basically drive themselves now. They have a mode you can do that, and you can. I saw a video of 2 guys riding one while I was driving. Even a regular Ford, my friend works at a Ford dealership, it has lane correction. If you start to drift, it puts you back in. That's a lot of velocity data coming in, a lot of sensors and reading it in. Variety is just variety is just the different types of data. What's veracity? Let's do it. Yeah, I think in Project Lead the Way, I don't think it's veracity. I think they have a different word one in there. So volume is how much we're creating. So zettabytes or brontobytes. I've never even heard of a brontobyte, but
Must be big enough to store brontosaurus.
so they're saying the beginning time in 2008 on this one. That'll soon be generated every minute. So I mean that's a lot. And then we get into this whole idea of distributed systems. Remember when we talked about NoSQL and databases? And some of the reasons was we need to be able to store it super fast, but we don't care if it's a little bit inaccurate in some of that. That's where this comes in. If you have a ton of data coming in really fast, if you lose a little bit of it, what does it matter?
A brontobyte is, which is one with about not many zeros.
Yeah, it's big. So and then the whole distributed thing, these need to be easily spread, which the around system, the NoSQL does. Velocity, the speed at which it's generated. So viral messages is a good example. That's fast. I'm thinking of even faster, like some of the sensor stuff.
1 billion gigabytes.
1 billion gigabytes. Yeah. Variety. So this is where structured data fitted neatly into tables. That's basically what we did in database class, right? All of that's it's relational databases. But now they're saying 80% of the world's data is unstructured. Text, images, that's a whole bunch of bits, zeros and ones, but how do you store that in any structure? There isn't really one. and there's whole NoSQL databases. I was doing more research into like MongoDB, which is the one we talked about, which is basically a file storage database intended to store images and documents and things. Yeah, so you were exactly right on veracity. So refers to the messiness of, or trustworthiness of the data, how valid it is. So accuracy is less controllable. You need to be, when you're not dealing with a perfectly structured data in a relational database, you need to be able to process that. And if it's messy, and yeah, you have to have fault tolerance to like handle that stuff. So turning big data into value. So what do we do with all this data? There's some obvious things. Then, like I said, like orbital shift, there's a ton of data that we store. That, what do we do with it? The big thing you're going to encounter in the business world is if you get a job and they have some big data sets, they're going to want you as information system IT people to figure out what can we do with that to make money, because that's ultimately the goal of business. That's what you got to always keep in mind as businesses try to make money, which seems obvious. Sometimes people forget that. So, yeah. Hey, I'm surprised at how often people forget that. And then in business, I was surprised once I was in it at how often that concept lets people throw out all morals and other things. So, I mean, you're dealing with all sorts of concepts there. I had a thought. Oh, I know a guy who I went to computer science through with the master's with him. He works at St. Pat's. He writes database queries. They track all the records of everything, obviously. And a doctor will come up with an idea. We think this factor might be contributing to negative outcomes. And then his job is to write SQL queries and pull that huge data set to try to show, is that true or not? And then if it is, what can they do to better that? So his whole job, he's been doing this for a while, kind of before they even called it big data, is trying to interpret that to, a hospital, they're not trying to make money, it's a nonprofit, but to get better outcomes. And have less people have return visits to the hospital and less people die, and that's sort of their goal. Well, if they died in the hospital. So basically here they're just showing a fancy graphic about turning it into value. Yeah. Right. So here's an example of kind of targeting customers. So adding in the social media, text analytics, sensor data to try to make predictions. So try to predict customer churns, how many customers are you going to use. Retailers can predict what products will sell. Car insurance companies understand how well their customers drive. You can do that progressive thing, right, that you plug into the OBD port and it tracks everything about your driving, and then either they say, you're a good driver, we can give you a great rate, or we won't insure you because you're hot rodded everywhere you go, right? So if you drive like a grandma, that's probably a good thing to try to see if you can get a good rate. But if you're not, then you like to gun it everywhere, you're probably better not even bother with that. So
It's all listening on YouTube. Mr. Randy is currently setting his competition progressive.
yeah.
You can be his spokesperson. Right, progressive.
Yeah.
You'd be like Allstate.
That could be the counter to the Allstate guy.
Progressive, keeping you safe.
So big data can optimize processes. So a lot of that is right up the alley of this whole systems analysis and design, right, of looking at processes and improving them. So of course, if you can come up with a predictive model, if you can analyze social media data and get a trend that you think this new toy is the hot Christmas thing before the other stores figure it out and order more, you're going to make more money. If you can forecast the weather and realize what impact that's going to have on your sales and modify your staffing accordingly, there's a ton of places this can be used. And then the whole supply chain routing. If the store gets a shipment of goods, it's always been pretty static. Like they placed an order, we need this stuff. But I assume Walmart probably has a sophisticated enough system to reroute some of that stuff to other stores based on RFID, how close something is to here. Well, this was supposed to go here, but this other store's stock went down quicker, send it there, and then shuffle it around, re-optimize the whole thing. The local company Logicis, or I guess it's Edgen Law now or whatever, they had built their whole business on optimizing bus routes. So
I played with it.
yeah, so that's where they started. They do other things, but it's here. These kids need picked up, and you have this many buses. How do you optimize that so there's as few left turns as possible? Because those waste time. UPS does the same thing. My uncle used to drive for DHL, and they got in trouble if they made too many left turns in a day. It wastes gas because you have to sit there. So optimizing processes, including health. So this is right up the alley of looking at the health data. We're collecting a lot of data from wearables like this. This is a Garmin device, and just earlier on my phone it came up with this insights thing where it compared my activity patterns to other people and then tries to suggest things I could do to improve.
Quit sitting in front of a computer.
Which is obviously looking at a lot of data, right? So, yeah, there's a lot of cool stuff out there now. This whole analyzing social media to get outbreaks, there's been a lot of movement with that. Like, if enough people say they're sick and they can identify where that is, they can start to identify an outbreak before those people even go to the doctor or anything even happens. And there's been examples of this. Cures, people doing searches for things, leading them to kind of predict. The problem is a lot of this stuff is still pretty fragmented, right? So someone out there might be analyzing that, but unless it's the CDC or someone that can actually do something about it, it doesn't really matter. So security, we've talked a lot about this, catching criminals. It's just, these are walking that line between safety and liberty and all that stuff. Sports performance. So they're starting to put in helmets, collision detectors to try to get more information about concussions and the impact on the brain. The sensors are small enough, they can put them even in balls. Golf clubs, you can buy a thing that you stick in the butt end of your golf club grip. And it tracks your swing path and tells you all sorts of information about it. Yeah, there was a glove, a thing you clipped onto your glove that did it. There's also an app you can take your iPhone and hook it on your putter with they sell the little thing, and then it tracks your putting stroke. And there's all sorts of, I do triathlons and stuff, and I wear a triathlon watch that tracks all my swim metrics, everything you could ever want about your biking and running. The question always then is, what do you do with that? Like, you can look at your running cadence and say, well, I should have run with a faster cadence, but I don't know. Like, I'm a data person. I love collecting data. At times, I question what I'm doing with all of it.
Oh, I have 1,200 terabytes of data.
I mean, I've used mint.com tracking every single thing I've bought since 2008. I have 8 years of data in there. I kind of budget with it and stuff, and every day I go in and I relabel and redo anything that's off, and I keep it perfect. But it's almost more for the sake of keeping it perfect than an actual practical purpose. I'm just that kind of person, I guess. But I don't know that it's helped me save money or be more financially responsible. I can't really say for sure that it has, but improving and optimizing cities. So they do a lot of this with traffic. We could save a lot of time with stoplights and stuff if they're. I mean, they'll reprogram them now manually, but if it's all fed into one common system that optimizes when they're green and when they're red, it makes a big difference. You can keep the flow going through. Like they're saying, especially with public transportation, buses and trains, and routing things so they're not hitting the same place at the same time. So basically, it's endless. And they're just saying here, like any business that doesn't consider implications, again, this is where you come in. If you can make recommendations either to data that could be collected or data that's there, things that it could be used for. Here's the book. I guess I should give a pitch since I stole the slides, right? Big Data, Using Smart Big Data by Bernard Marr. So the other slideshow, which is really short, I wanted to pull it up because he added a fifth B into this word. The 5 Bs. Yeah, value. So he's combining in the V that he did already speak about in the other one. So volume, variety, velocity, value. So that is the key thing. The others are what makes the data big, but without the value, I can't say it's pointless because you could collect data and not realize there's a purpose of it for a couple of years. So, but ultimately, the value is what drives it. I'm sure the bank is into analyzing transaction data, and there's a ton of tons of things that can be improved. So, I mean, like I said at the beginning, I think to some extent big data is putting a fancy word to stuff that's been around. But some of the things like the volume and the velocity, like they're saying 2003, we just weren't producing data like we are now. So I think it's good for you to be aware of. So I will post specific details tonight about Project Checkpoint 2. It will be very similar to what you did last Thursday. You're going to check in on what you did. Tom, what did you do? You get interviewed for a job, right? Oh, you did find a new one.
So actually, I call it a tweet, put it in there, and it doesn't ignore the white space.
Yeah, you made a change. Looks good. All right. So, farewell on you.